And we're on to D. Now D, I wouldn't expect anyone to have a graph of D in their brains. I kind of know what this graph looks like. It's the graph of sine, but we are reducing it by a linear factor. So what looked like this originally, right, our two sines, we had the fatter amplitude, is going to be like at the same time minus all of this. So it's going to do like a weird squiggly thing. I can't. I'm very bad at drawing things, but that's what's going to happen. So we'll look at Desmos after because I love to have a visual of what's going on. But let's go ahead and work through our work for the candidates test to find our absolute max and min. Just like before, we need our y prime. So we'll have a 2 cosine of x minus 1. Pretty sure this is exactly the same one we saw in our intervals of decreasing and increasing back in 5.1.1. So if we set this equal to 0, because cosine's continuous, it will never be undefined, right? Its domain is all real numbers. So we set this equal to 0, we find all the values of cosine of x is equal to 1/2. Which means my x must be, my critical values for x, whenever cosine is 1/2, which is pi over 3. And then this is where I struggled last time. I had to subtract pi over 3 to get myself down into quadrant 4. So 2 pi minus pi over 3 is 5 pi over 3, she says as a question mark. There you go. So those are our critical values. We also, of course, need to check our endpoints. So let's go ahead, and make our table. All right, so we have our x's, our candidates, right? Technically, there's an infinite number of x's here, but we're only looking on this closed interval. I should have checked for continuous and closed. Sine is continuous. X is a linear function, that's continuous. Combining them still creates a continuous function because we're doing an addition subtraction situation. Division gets you in trouble. So could composition, theoretically. Could it? I don't think so, actually. We'll come back to that another day. And then we have our closed interval. So let's go ahead. We're going to find some y's. We'll do our endpoints and then also our critical values. And again, we are plugging back into the original function, our OG function. So 2 sine of x when x is 0, this is just going to be 2 times 0 minus 0. Okay, it's not exciting. Remember my little sketch? I feel like it's going to come up. I might get a maximum somewhere before it drops back down, but definitely doesn't feel like anything special. Let's check out pi over 3. So now we have 2 times sine of pi over 3. Well, if cosine is 1/2, sine must be root 3 over 2. Minus, I already forgot what we were doing. Oh my gosh. Why would you give me things like this? I don't know what this is. I mean, like, I'm just saying, I need a decimal approximation to know something is bigger than something else, because when we're talking about root 3 minus pi over 3, I'm just like, bruh, I don't know. All right, so as I expected, slightly larger, because we're at that like peak of the sine function, but it's been like shifted down because of that slanty pit that we've subtracted, right? That linear function with a slope of -1. All right, so then we keep going. 5 pi over 3, all students take calculus. We're in quadrant 4. Sine is negative. So this is going to be 2 times a negative root 3 over 2 minus 5 pi over 3. Maybe I'll be good and do it on my actual calculator right here. I hate it, but I'll do it. All right, let's see. 2 minus, not minus, it's 2 times negative square root. I really hate that I'm doing this. Next time I'm using Desmos for the calculator. We've got one more of these, and I'll suffer through it for this last one. 5 pi divided by 3. Cute? Cute. All right, negative 6.97. Now, to me, that was probably right next to the minimum, and then the shifting down. I think maybe we're coming back up. Trying to think, yeah, the sine curve comes back up a little bit. So I'm thinking we're at the coming back up a little bit, and it's questionable to me whether or not that's happening faster than that linear bit, but we'll see. We'll see. So last one, 2 times 0. Whew, that's easy. Actually, I don't need to do anything because I should be able to do 2 pi in my head. I laugh because it's really 3.14 times 2 is 2.8. Okay, 0.28. There you go. So as expected, we've got our maximum and we have our minimum. Boom. We should write those sentences. I'm going to be a little lazy. We're getting a little long, but we'll see. Do I have a Desmos? Yes, I do. But it's way over on my other screen. So let me go ahead and bring it over. Okay, so here's my cute Desmos. We were looking at 2 sine of x minus 1. No, not minus 1, minus x. Yes, see, there you go. Like I said, the sine curve, but there you go. Isn't that fun? That's cute. And we said maximum here, pi over 3. Boom. And minimum here at 5 pi over 3. There you go. When you have Desmos, all of this calculus seems kind of unnecessary because you can just toss it in Desmos and click on the graph. You could even have gone ahead and done those restrictions, putting that closed interval on there by using some braces. So then you only see the part of the graph that we're really caring about. Doesn't show my cool little pattern that I was talking about. But you could definitely find your min and max straight from there. It even has sort of like almost all of our critical values are here, right? We have all of them because the min and the 2 critical values. Oh, maybe it's not going to let me put the 2 pi over here. Yeah, but there she is. All right, so that's it. Talk too long. The absolute maximum is 0.685 at pi over 3, and the absolute minimum is negative 6.97 at 5 pi over 3. So this is an example where had you just used the first derivative test, you would have gotten the right answers, but not for the right reasons. So no, if you don't test everything in the candidates test, or at least show that you thought about them, you will not get full points on the quiz this week.